Hello, you're back again. I'm so happy to see you again because we are continuing with lesson 3 of trigonometric functions and their identities. Okay, and as you see from before, from the other videos that we showed trigonometric identities and the reciprocal identities, which are also called the fundamental identities, and the Pythagorean Theorem identities. Now we're going to apply most of these techniques or most of these identities to solve a problem concerning dealing with the values of these functions. And we want to find the values of these remaining trigonometric functions given sine theta. Now remember the last video? We did the same thing, but we were given another value of cosine theta. But now we're given the value. We're going to be given the value of sine theta. However, we have to evaluate. Look at the right triangle first, don't we? Because we have values at B on the opposite side, and we have a value at C, which is the hypotenuse. Still, we must find the adjacent side, A. Now, how will we do that? Well, we have to consider A squared plus B squared is equal to C squared, the infamous Pythagorean Theorem. Now, we'll just plug in values and solve for A. For A, that is. Not A squared has to be isolated. However, we still have to break it all the way down and solve for A and get a value for A. So B is 1 squared, or 1 squared. C is going to be 5 squared. So it's going to be A squared plus 1 squared equals 5 squared. So A squared plus 1 equals 25. So therefore, we solve for, or we isolate the variable A squared, we get A squared is going to equal to 24. So guess what we have to do? Remember the last video, or one of the very last videos, we had shown how to do that. We had to solve for A. We can't leave that there like that. Remember that. We have to actually solve, get rid of the power, or excuse me, get rid of the exponent 2 by what? Multiplying 1/2 to the exponent, and we have to do the same thing to the other side. This is understood as 24 to the first power. However, anything to the power of 1/2 is always considered to be that square root radical. So this cancels out, and this becomes A is equal to the square root of 24. So now we want to simplify that and put that in radical notation. So if we do this, 6 times 4, breaking this up, square root of 6 times the square root of 4. Well, the square root of 4, of course, is 2. So your A value is going to be 2 times the square root of 6. Usually in square roots, there's a plus or minus variation. However, when we're dealing with distance or measurement in a sense, it's never negative. So it's going to be a positive 2 times the square root of 6. Now, we can go on here and proceed to finding our trigonometric values. Cosine theta being what? Being the adjacent side over the hypotenuse. Now that we have the value of A, we can go to work, can't we? So with this, we want to show that A is 2 times the square root of 6 divided by the hypotenuse, which is 5. So look what we have there. We have our value. We have our cosine theta. Let's continue. Tangent theta, which is the opposite over the adjacent, what we could do is take these values, take the value of b, 1 over what? 2 times the square root of 6. Now, what problem do we have here? What did we say last time? Basically, you don't want to have any radicals that are in the denominator. So we must rationalize the denominator to simplify it. So 1 over 2 times the square root of 6, we just want to take this and multiply the square root of 6 to the top, the numerator, and square root of 6 to the denominator as well. So this equals square root of 6 over 2 times the square root of 36, which will give you 6 divided by 2 times, what's the square root of 36? The square root of 36 is going to be 6. So here, the value tan theta is going to be the square root of 6 over 12. So you have your tan theta, which is going to equal to, if everybody can see that, get a nice good picture of that. That is your value. Tan theta is the square root of 6 over 12. Now, we still have more work to do. So we have to find cosecant theta. And to find cosecant theta, what will be our C value? Our C is 5 over B, which is what? 1. So cosecant, excuse me, not secant, but cosecant would be equal to what? 5. So cosecant theta is equal to 5. There we go. Now let's keep going. We have to consider secant theta is equal to the hypotenuse over the adjacent side. So again, C is 5, and what will be A? 2 times the square root of 6. So again, we have to do what? We have to rationalize the denominator because it's not simplified. So 5 divided by 2 times the square root of 6. And when we do this, breaking this down thoroughly, we have 5 times the square root of 6 over 2 times the square root of 36, which is going to actually be 5 times the square root of 6 divided by 2 times what? Square root of 36 is 6. So 2 times 6 is 12 there. So your secant theta is going to be 5 times the square root of 6 divided by 12. We want to make sure that everybody at home is getting this. Everybody at home, everybody in Math Magic Land, right? We can't forget those people there. To keep trying and also work these problems thoroughly, break everything down. Professors like to see work shown and showing how you go from each step, from step to step to get the solution. If you're having problems or having trouble, if we're going too fast, then I encourage you to stop the tape, stop the video, and go back, take your time, take a deep breath, copy the notes, and try to ingest everything that's being taught here. Now, did we do everything? I think we have one more identity, don't we? And I believe it's cotangent. Cotangent theta. So, I gotta get a trusty pen here that works. Let's go here with red. Okay, what is A? A in this case is still 2 times the square root of 6 over what? What's b? B is 1. So there you have it. Cotangent theta is equal to 2 times the square root of 6. So we have basically found all the values for the remaining trigonometric functions given sine theta, which we given earlier, which is actually 1 over 5, which was given here according to the triangle here that we see. And we continue on to find the values of the rest of the trigonometric functions. Now, I'm going to show you another method that we use to find these things. And we're going to use the fundamental identities to find these values. So if you will, follow me over to the other side. If you notice, here's the second method. What do we see right here? What did we talk about before? What did we derive? Actually, the last time we spoke about Pythagorean Theorem identity. Sine squared theta plus cosine theta is equal to 1. So, what was sine? What was sine? What was sine theta? Sine theta was given, right? So sine theta was given, so we plug 1/5, 1 over 5, into here. Now you notice that this is squared. So this is to the second power, plus cosine squared theta is equal to 1. So you plug it in the values. So this will be 1 over 25, plus the cosine theta is equal to 1. So what do we have to do? We have to solve for cosine squared theta. And how do we do that? We take negative 1 over 25 to both sides of this equation, and then we finally get here cosine theta is equal to 24 over 25. Question is, are we done yet? Absolutely not quite, not yet. Because here we have to solve for cosine theta. Not so much as cosine squared theta. Well, we had isolated the variable, of course, but then we have to break it all the way down and solve for cosine theta. So how do we do that? Well, remember we said a couple of videos ago that basically that cosine theta is written like this. It's understood to be this way. It's not necessarily written like this, but that's what it's actually saying. However, it's more appropriate to write it this way. Remember that? Well, it's okay to write it this way for right now, because what are we doing? We have to isolate the variable, and we have to solve for cosine theta. So we're going to multiply 1/2 to the exponent 2. And what you do to one side of the equation, you must do, of course, to the other side of the equation. So 24 over 25 to the 1/2 power would be what? Cosine theta is equal to the square root of 24 over 25. So breaking this down and reducing this and simplifying this will give you 2 times the square root of 6 divided by 5. 2 times the square root of 6 divided by 5. Now, we're done. So basically with this particular function, trig function, so here we say that cosine theta is equal to 2 times the square root of 6 divided by 5. Let's continue on. We have tangent theta is equal to sine theta divided by cosine theta. We have to find this value for this. What identity do you think this is? Anybody out there in TV land, can you tell me what this is? Can you wave your magic wand or your magic mirror and just kind of give me the answer? Can you? Well, this is actually a what? The quotient identity. This is a quotient identity. You have to be able to recognize these things. That way you can apply it and find your solution very, very easily. However, the quotient identity says that sine theta, remember, is equal to 1/5, 1 over 5. Cosine theta, of course, we found, is 2 times the square root of 6 divided by 5. All we do basically is our simple division of fractions, don't we? And remember the radicals now. When you take the reciprocal of change the sign operation symbol to a multiplication sign, and understand that you got to take the reciprocal of the second term, or the second constant here. Look what we have. We have the radical in the denominator. So you have to rationalize the denominator. Very, very important. So after multiplying this, you come with 1 over 2 times the square root of 6. So you rationalize the denominator and simplify it. And then you come up with tangent theta is equal to the square root of 6 divided by 12. Moving right along. Cotangent theta is equal to, what type of identity is this? This is the reciprocal identity. Okay, so cotangent theta is equal to 1 over tan theta, which is equal to 1 over the square root of 6 divided by 12. And after you do all your calculations and do all your basic arithmetic, including rationalize the denominator and simplify it, you're going to be coming up with the cotangent theta is equal to 2 times the square root of 6. Again, we're not quite done yet. We still have a few more identities to go. There it is, right there. So this is the line that you want to see right here. So after you change the operation symbol to multiplication, what you want to do is take the reciprocal of the second term and then, of course, start to simplify your expression here. So 5 over 2 times the square root of 6. Here again, we have a what? We have a radical in the denominator, so we must rationalize the denominator. And when we do that, we come up with the final answer of this thing to be what? Secant square, or secant, excuse me, secant theta is equal to 5 times the square root of 6 divided by 12. Now, look at this very, very closely, because we have one more identity to do. And with this last identity, so cosecant theta is equal to 1 over, there we go. 1 over sine theta. There we go. So what is sine theta? Remember, it'll be 1 over sine theta, which is 1/5. So look what we have here. We don't have any radicals or anything, so basically we rewrite this as a division expression. 1 times, or usually I don't like to use x's when we're dealing with algebra because as multiplication symbols, because it's always mistaken for the variable. That's why in higher level mathematics we want to use a dot or a parenthesis as such. So 5 over 1, that's going to equal to 5. So therefore, cosecant theta is equal to 5. Very good. So this is how you find the values of the remaining trigonometric functions given a particular value or a particular identity or a particular trigonometric function. You use and you find all the rest of the functions, the values, by using those functions, and their identities. So, thank you very much for listening. We will continue on doing other trigonometry videos and other mathematic modules such as calculus, basic math, financial math. We'll try to accommodate the world with everything that they need to become successful. And we're looking forward to seeing you soon, right when you meet the what? The professor.